go to page 9 in your journal and take a look at the core concepts. On this page, we talk about horizontal translations and vertical translations. Looking at a horizontal translation, that means the plus or minus a number is inside the parentheses with the x. So you might see an example would be something like f of x equals x minus 5 all squared. This would tell me it's a horizontal translation 5 units. If it's minus, it's moving to the right, and if it's plus, it's moving to the left. Then if we look at the vertical translations, that means the number is added or subtracted at the end. So an example of this might be something like f of x equals x squared minus 1. That would shift the graph down 1. So a plus will move it up, and a minus will shift it down. Now go to page 10 of your journal and take a look at the reflections in the x and y axis. Here we can see if I have a reflection in the x-axis, there's a negative outside the function. So an example here might be negative x squared. And this will reflect it over the x-axis. If I have a reflection in the y-axis, you can see the negative is inside the parentheses. So an example here might be something like negative x squared. Now in this case, if it's squared, anything squared is going to be positive, so this would be the same thing as x squared, and when it's reflected over the y-axis, the graph actually looks exactly the same as a normal quadratic function. Now let's take a look at your notes packet and look at example 1. For part A, we want to write a function whose graph is a translation 3 units down from the graph f of x. So this means for part A, we're going to have g of x equals f of x minus 3. So now just replace f of x with 2x plus 1. Combine like terms and we get what? 2x minus 2. And there's your final answer for part A. For part B, I want to write a function h of x whose graph is 2 units to the left. So if you look back at the core concepts, left is going to be plus, so we're going to say this is f of x plus 2, which means I replace the x in my function right here with x plus 2. So I'm going to have 2 times x plus 2, all plus 1, and then distribute your 2. So my final answer will be what? 2x plus 5. And there's my final answer. Looking at example 1a, I have an absolute value function. So for part A, I want to write g of x, and it's a translation 3 units down again. So I just take f of x and subtract 3 on the outside. So this would just be 2 absolute value of x minus 3, and we're done. For part B, it's a little different. Part B is going to be a translation 2 units right, so that would be x minus 2, and then we'll get 2 times the absolute value of x minus 2, and that's all. That'll be our final answer here. We do not distribute the 2 in absolute value. We only distribute with parentheses. Now let's take a look at example 2, writing reflections of functions. If I want to reflect in the x-axis, I'm going to say g of x equals negative f of x. So now replace this whole equation, f of x, in parentheses we've got absolute value x plus 3 plus 1. So when I distribute this negative, my final equation is going to be negative absolute value x plus 3 minus 1. And then for part B, I want to write a function that's reflecting in the y-axis. So that's f of negative x. And I'm going to write that as negative x plus 3 plus 1. We don't really like this negative x to be there. So if we take out the negative x and say negative x minus 3 plus 1, this negative 1, since it's in absolute values, goes away, and we'll have absolute value of x minus 3 plus 1 as our final equation. Looking at example 3 on the next page, we're going to focus on stretches and shrinks. For part A, we want a function whose graph is a horizontal shrink by a factor of 1/3. So this is going to look like f of 3x. For horizontal shrinks, we always do the opposite, the reciprocal of the factor, and we multiply on the inside.